Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester BSc Physics honors syllabus and belongs to CBCS model. In our last class we have been discussed brief revision of complex numbers and their graphical representation and few numericals. In this class we are going to discuss Euler's formula. Euler's formula and polar form of complex number and principle of argument corresponding numericals. Okay, so this is your lecture number 2. So let's start. So as I told that in our last class we have been discussed these things: revision of complex numbers and nth power of I, properties of algebraic operations, graphical representation of complex numbers and few numericals. So in this lecture number 2, first we have to discuss Euler's formula. The Euler's formula is e to the power iota theta, that means exponent of iota theta will be equal to cos theta plus I sin theta. So this is the 3-mark questions you can get in your exam. Okay, to find the Euler's formula, consider the expansion or Taylor's series about z0 equal to 0 of e to the x. See, about Taylor series you are going to study, or we are going to discuss in our forthcoming lectures. So here we are going to use the Taylor series or the expansion of e to the x or exponent of x, or we can say the Taylor series about z0 equal to 0. So expansion or Taylor series about z0 equal to 0 of e to the x is nothing but 1 plus x square by 2 factorial plus x cube by 3 factorial plus x to the 4 by 4 factorial plus x to the 5 by 5 factorial and so on. Now we are going to consider x equal to iota theta. So instead of x, if we are going to put iota theta, then this series will be 1 plus iota theta square by 2 factorial plus I theta cube by 3 factorial plus I theta to the 4 by 4 factorial and so on. That implies e to the iota theta will be equal to 1 plus, this will be iota theta, this will be I square plus into theta square by 2 factorial plus I cube theta cube by 3 factorial I to the 4 into theta to the 4 by 4 factorial I to the 5 into theta to the 5 by 5 factorial and so on. That implies e to the I theta will be equal to 1 plus iota theta. Here you can see I square is nothing but minus 1, so it will be minus theta square by 2 factorial. I to the 3 is nothing but minus I. Already we have been discussed. You can check the previous lecture for nth power of I. So I to the 3 will be minus I, so it will be minus I or iota into theta to the power 3 by 3 factorial. I to the power 4 will be 1 into theta to the power 4 by 4 factorial, and iota to the power 5 is nothing but I into theta to the power 5 by 5 factorial. I to the 6 is nothing but your minus 1, so it will be minus theta to the 6 by 6 factorial and so on. So here we are going to segregate the real part and imaginary part of this series. Here you can see this is the real part of this series 1. This is your minus theta square by 2 factorial. Here this is another real part, theta to the 4 by 4 factorial minus theta to the 6 by 6 factorial and so on, plus iota into, that means all the imaginary term I have written separately, theta, this one, this term, theta, this term, minus theta cube by 3 factorial, this one, plus theta to the 5 by 5 factorial, already I taken common and so on. Let this is your equation number 1. Okay, now consider the expansion or Taylor series of about z0 equal to 0 of sin theta and cos theta. We know the expansion of sin theta is nothing but your theta minus theta cube by 3 factorial plus theta to the 5 by 5 factorial minus and so on. Cos theta expansion is your 1 minus theta square by 2 factorial plus theta to the 4 by 4 factorial minus theta to the 6 by 6 factorial plus so on. Now consider equation number 1. Here you can see that this series is nothing but this one. Here you can see 1 minus theta square by 2 factorial. Here is the same term, theta to the 4 by 4 factorial minus theta to the 6 by 6 factorial. So instead of this series we can write cos theta. Okay, so instead of this series we can write cos theta. So here you can see this one, this series is nothing but this one. So instead of this series we can write sin theta. So hence equation number 1 will be how much? E to the iota theta will be equal to this one, will be cos theta plus iota is there, iota or I into sin theta. So this is the famous Euler's formula that you have to remember, very much essential for different type of calculations in your complex analysis. Now we are going to go for polar form of complex number, right? For that, consider a complex number x z equal to x plus iy is a complex number which is located at point P, this one. Okay, the vector z is make an angle theta in the counterclockwise like this. So counterclockwise means we have to consider as plus theta. If we are going to consider clockwise angle, then it will be minus theta, but that we are going to discuss in later. But you have to remember, whenever we are going to consider counterclockwise angle, we have to consider as plus. When we are going to consider clockwise somewhere theta, it will be minus. Okay, so here theta is the counterclockwise direction from positive x-axis. This is the positive x-axis, this is the positive x-axis. From the positive x-axis, this is the counterclockwise theta, which that your complex number makes with that real axis or positive x-axis. From this triangle OPM, this modulus or this distance O to P or modulus of this complex number is considered as R, which will be equal to x square plus y square root over. That already we have been discussed in our previous class. In polar form, considering this triangle cos theta, if we are going to consider for this triangle, this will be x by r. Here this is the x, that means horizontal component by this diagonal, so x by r, that implies x will be r cos theta. Similarly, if we are going to consider sin theta for this triangle, we can find y equal to r sin theta. So z mod or modulus of this complex number, which will be represented as r, will be x square plus y square root over, can be written as r square cos square theta plus r square sin square theta. So if we take r square common from this, from the root over, then we can found r into cos square theta plus sin square theta, that will be r. Okay, so here we found that the modulus of this complex number will be equal to r square cos square theta plus r square sin square theta root over in the polar form, right? Now we are going to represent this complex number in the polar form. So initially we have been represented the complex number in the Cartesian form as x plus iy. So here we found x equal to r cos theta, y equal to r sin theta. If I am going to substitute over here, z will be r cos theta plus I r sin theta. This is the complex number in the polar form. Taken I r common, so it will be r into cos theta plus I sin theta. Cos theta plus I sin theta, according to Euler's formula, is nothing but e to the iota theta. So we have to substitute over there. Instead of cos theta plus iota sin theta will be e to the iota theta. So z will be r e to the iota theta or I theta. So this value will be e to the iota theta is nothing by using Euler's formula. Here angle is considered as in the form of radian, which makes with positive x-axis or real axis called amplitude. This theta is called as the amplitude of z, or in short it is represented as AMPZ. Okay, this angle theta is also called as the argument of z or ARGZ, right? If we are going to consider this triangle, then theta is nothing but tan inverse y by x. If tan theta, if we are going to consider tan theta, then y by x, so theta will be tan inverse y by x. So either way we can consider also. From here we can found the theta will be cos inverse x by r or sin inverse y by r. Cos inverse x by r, so r is nothing but your x square plus y square, x square plus y square. Similarly, theta also can be written as sin inverse y by x square plus y square. So either way you can found the theta value. Note what we have to note here: theta is called the argument of z, can be replaced by theta plus 2n pi, right? So here n is nothing but your 0, 1, 2 and so on. If we are going to put 0, then theta is nothing but theta. If I am going to put 1, then theta plus 2 pi is equal to itself theta. Here you can see this is the theta. If I am going to consider again 2 pi, in the same value we are going to get. So argument of z or theta can be replaced by theta plus 2n pi, right? So argument of z will be always taken from positive real axis. This is most important that you have to remember. I put it over here the hashtag that argument of z always we have to consider from the positive real axis like this, counterclockwise direction, along with the counterclockwise direction, right? Okay, now we are going to go for the principle of argument. So here principle of argument is represented shortly as capital ARG Z. Principle of argument Z is denoted by ARG Z, capital ARG Z. Okay, here ARG will be theta or will be argument of theta if theta lie in between minus pi to pi. Otherwise principle of argument capital ARG will be argument of Z minus 2n pi. This is the most important expression that you have to remember. Okay, minus 2n pi, argument of Z minus 2n pi. We are going to solve some numericals from which you can clear that what will be the argument of the complex number and corresponding principle of argument. First question is that write the polar form of this one, Z equal to 1 plus root 3i, and then find out argument of Z and principle of argument or capital ARG Z. Okay, the given complex number is your Z equal to 1 plus root 3i. If I am going to represent this complex number, so this is the 1 unit 1, and if I am going to consider root 3 something 1 point something, so the point will be lie over here. So the location will be 1 and root 3, and this will be your complex number, complex vector, and its modulus r will be here. Modulus of complex number or r is nothing but square of the real part plus square of the imaginary part root over. Here real part is 1, imaginary part of is your root 3, so 1 square plus root 3 square root over will be 2. But in the polar form, if we are going to write in the polar form the complex number, that is your, in general, this is your Z equal to r into e to the I theta. So here we found r equal to 2, but theta, how we are going to find out? Theta will be tan inverse y by x. So here y means imaginary part of the complex number, that is your root 3, by x is nothing but the real part. See, this is in the form of what? X plus iy, right? And tan inverse is nothing but, sorry, theta is nothing but tan inverse y by x. So here y is nothing but root 3 and x is nothing but 1, root 3 by 1, that is your tan inverse root 3, that is your pi by 3. So for this complex number, the polar form will be Z equal to 2. See, r is your 2 into e to the power I theta is your pi by 3. So this is the polar form of this complex number. Okay, now we are going to find out the argument. So here you can see that this complex number located at this point. So if I am going to join a line or vectorial form, this vectorial form of this complex number makes an angle theta with positive real axis. This is the positive real axis, this is the theta. That means this complex number lie in the first quadrant. This is the first quadrant. Okay, so this theta will be how much? We found that pi by 3. So argument of this complex number is your pi by 3, right? And this angle is lie in between minus pi to pi. So obviously argument of Z will be principal of argument of this complex number. So clearly I have written in the note that theta is in the first quadrant, that is your less than pi. So this theta is less than pi, so hence theta equal to pi by 3, which will be called as argument of this complex number or principal argument of this complex number, right? Now we are going to go for another numerical, that this one. First we have to write the polar form of this complex number minus 1 minus I, then we have to find out the argument and principal of argument of this complex number. Okay, in the question given complex number is your minus 1 minus I. So in general the polar form is your r e to the I theta. So for that we have to find out r and theta. So r will be nothing but use your what, modulus of the complex number itself. So r equal to real part square plus imaginary part square root over. So here real part is minus 1 square plus imaginary part is your also minus 1 square root over is your root 2. From the figure argument, that means we always, you have to remember that whenever you are going to calculate the argument, that means the angle make with positive real axis. This is the positive real axis to the vector. So this is the point. See, here it has been given that -1 minus I. That means the location of the complex number in your third quadrant, first to second, third quadrant, -1 and -1. So this is the location. So this is the vectorial form of the complex number. So this vector makes an angle this much with positive x-axis or positive real axis. So this is the positive real axis, this is the negative real axis. So with the positive real axis, this is the angle. This angle is called as the theta and also called as the argument of the z. This is the most important that you have to remember. With positive real axis, what is the angle made by the vector, complex vector, is called as your argument of that complex number. Okay, so here you can see that this angle is nothing but here up to this much is your pi and again another angle alpha. So here argument of z, here I have to write theta will be equal to argument of z is nothing but up to this much is your how much, pi. Okay, then another angle is your alpha, this is your alpha. So argument of z or theta is nothing but pi plus alpha. Now we have to find out alpha. Consider this triangle tan alpha. See here, this value is your -1, this value is your -1 also. From here, from this given complex number, if it is location is this one, then this value, this length is -1, this length also -1. So if I am going to consider this triangle, then tan alpha is nothing but this one, y by x. This is your height, this is your base of this triangle. So -1 modulus by -1 modulus will be equal to 1. So this angle alpha will be tan inverse 1 is nothing but pi by 4. So argument of z will be how much, pi plus alpha. Alpha is pi by 4. So hence argument of z will be pi plus pi by 4 will be pi by 4. This is your argument of the complex number, right? Now what will the principle of argument? First we have to check that this argument is in between -pi to pi or not. If it is so, then that argument will be itself the principle of argument. If it is not so, then we have to consider this one, argument of z -2n pi will be the principle of argument. So here you can see clearly 5 pi by 4. 5 pi by 4 means something. If I am going to consider 5 by 4 will be 1 point something. That means this value is greater than that of the pi. So the first we have to write the polar form. So hence if it is the argument of the complex number, so then the polar form will be how much? Here r into e to the power iota theta. Iota into theta is how much? 5 pi by 4, this one. But here argument 5 pi by 4 is greater than pi. Here 5 pi by 4 is more than 1. So obviously this 5 pi by 4 will be greater than pi. So hence argument of z not equal to our principal of argument of the complex number. So for that we have to consider argument of z will be equal to, sorry, principal argument of z will be argument of z minus 2 pi. Argument of z we found 2 pi minus 2 pi here. So it will be minus 3 pi by 4. The principal argument of this complex number here will be how much? Minus 3 pi by 4. Clearly try to understand clearly this numerical. Then whenever you are going to face any type of numerical, you can easily find out its corresponding argument and principal of argument. Here you can see in general we have been written argument of z equal to minus 2n pi. But here we consider only 2 pi. Why? See, in general we have been written principle of argument is your argument of z minus 2n pi. So here n equal to 0, 1, 2 like that. If I'm going to put 0, then argument of z will be equal to, sorry, principal argument of z will be equal to argument of z, which is not to be acceptable for this case. Now we are going to consider n equal to 1. Principal argument will be argument of z minus 2 pi. Okay, so here if we are going to consider this one, 5 pi by 4 minus 2 pi, this value will be how much? Minus 3 pi by 4. Minus 3 pi by 4. Here 3 by 4 is less than 1. So obviously minus 3 pi by 4 in between minus pi to pi. So this will be acceptable. Now we are going to consider n equal to 2. Then principal argument of z will be equal to argument of z, that is your 5 pi by 4 minus, if we have to put 2 over here, this will be 4 pi, right? 4 pi. Then what will the value? Value will be 5 pi minus 8 pi by 4. That means we can found 8 minus 5 minus, oh sorry, here 4 into 4, 16 pi. 16 pi minus 5 pi, it will be how much? 11 pi by 4. So 11 pi by 4 not lie in between pi to pi, minus pi to pi. We could not found this value. Okay, this value beyond minus pi. So hence f of n value greater than 2, greater than equal to 2 could not be acceptable. So n value will be 1 only. Okay, so hence only for that we consider 2 pi, and the value will be minus 3 pi by 4. And what will the angle here? Here you can see from this positive real axis to this much will be minus 3 pi by 4. This angle will be, entire angle will be 3 pi by 4. And as we are moving clockwise direction, so the value will be minus 3 pi by 4. Here you can see this is your up to this much, pi by 4, 2 pi by 4, 3 pi by 4. So this angle will be 3 pi by 4. As we are moving counterclockwise direction, so it will be minus 3 pi by 4. Okay. So in short, I'm going to revise this question once again, that if the point lie in the third quadrant, first you have to find out the argument. Okay, the argument will be f of pi, or not in between minus pi to pi. So for that principal of argument of that complex number will be argument of that complex number minus 2 pi. Okay, for this case it will be 5 pi by 4 minus 2 pi will be minus 3 pi by 4. Carefully observe this diagram. From here to here is nothing but your theta or argument of z. From here to here, this angle clockwise direction is your principal of argument. Okay, now we are going to go for another question number 15, that is your find argument and principal of argument of z equal to 1 minus root 3i. First we are going to locate this complex number. Here you can see the real part is your positive and imaginary part is your negative. That means the point will be located in the fourth quadrant, that is your this one. So in vectorially, if you are going to represent this complex number, this will be the vectorial representation of this complex number 1 minus root 3i, this one, right? Now here you can see that argument is nothing but angle made by this complex number or vector of this complex number with positive real axis from here to here. So this one will be your theta or argument of this complex number from here to here. So up to this much is your 3 pi by 2 and another alpha angle. Let this is your angle is your alpha, this angle. So argument of this complex number theta will be 3 pi by 2 plus alpha, this one. So this point located at here 1 minus root 3. That means this length is your root 3 and this length is your 1 and this angle is your alpha. So if we are going to consider this triangle and tan alpha, if we are going to consider tan alpha, here this is the height and this is the base, right? So 1 by root 3. So tan alpha for this triangle, tan alpha will be 1 by root 3. So alpha will be tan inverse 1 by root 3 will be equal to pi by 6. So argument will be equal to 3 pi by 2 plus alpha value is your pi by 6. Pi by 6 plus pi by 6. If we are going to add, then we can found 10 pi by 6. We found the argument of this complex number from here, from positive real axis counterclockwise. We have to move counterclockwise from here to here. Value is how much? 10 pi by 6. Is this angle is greater than pi? Yes, this angle, this argument z or this angle is greater than pi. So hence argument of z not equal to principal of argument. Okay, so principal of argument will be how much? Argument of z minus 2 pi. So here argument of z we found 10 pi by 6 minus 2 pi will be how much? Here you can see this is 10 pi minus 2 pi, so this will be 12 pi and this will be minus 2 pi by 6, that means minus pi by 3. So here we found principal of argument will be equal to minus pi by 3. So again and again I am going to tell to you, first you have to find out argument of z, that means entire angle make by the given complex number with positive real axis. For this case this angle, this is your argument of z. Then you have to find out principal of argument. If that angle is in between minus pi to pi or less than the value of the angle, if less than the pi, then argument of z, this question, first this question, argument of z will be equal to principal of argument, because here we found argument of z equal to pi by 3 as it is in your first quadrant. But in the second question, as it is in the third quadrant, so principal of argument is your argument of z minus 2 pi. So as it is for this question, as it is in your fourth quadrant, so principal of argument will be argument of z minus 2 pi, well will be how much? Minus pi by 3. Now we are going to go for another question, this one. Find find argument of z and principal of argument of z of the complex number, given complex number minus root 3 plus I. So first we have to locate this complex number. So here real part value is minus root 3 and imaginary part is your 1. So minus root 3, suppose this much, and 1 unit of height is this much. So the point will be located in your second quadrant, this one. So this is the point of the complex number where it has to be represented, and the vector form of this complex number is this one. This is the vector form of the complex number. Now what will the angle between this complex number, which is represented vectorially with positive real axis? So this angle is nothing but your argument of this complex number. So what will be this angle? From here to here is nothing but pi by 2, and another angle is your alpha, pi by 2 plus alpha. So argument, that means that implies theta is nothing but your argument of z will be equal to pi by 2 plus alpha. So this angle is nothing but alpha. We have to find out the alpha by considering tan alpha for this triangle, So this length is root 3, so this length also root 3, this length is 1, so this length also 1. So if we are going to consider this triangle and corresponding tan alpha, then value will be how much? Here this will be the height and this will be the base, as this is the angle phi alpha. Okay, so this length also 1, right? This length also 1. So tan alpha will be root 3 by 1, alpha will be equal to root 3 by 1, or tan inverse root 3 by 1, alpha will be equal to pi by 3. So here pi by 3, alpha is your pi by 3. So argument will be how much? Pi by 2 plus alpha, So pi by 2 plus alpha means pi by 2 plus pi by 3 will be equal to how much? 5 pi by 6. So here 5 pi by 6 value is less than pi. So hence argument of z will be equal to principal of argument of this complex number. That will be 5 pi by 6. So roughly you just remember that if the complex number will be in first and second quadrant, then argument will be equal to principal of argument. If it will be third and fourth quadrant, then you have to use this one. this procedure. For third quadrant this procedure, and fourth quadrant this procedure. That means first you have to find out the argument, then you have to find out the principal of argument. Okay, so another question is that find argument and principal of argument of z equal to minus 3 minus 4. So if we are going to locate this locate this complex number. So suppose this is minus 3 and this is your this side 1 2 3 4 1 2 3 4. So here this is the point where the complex number will be located. This is the minus 3 and minus 4, and this is the vectorial representation of the given complex number. So this angle will be the argument, and as it is more than pi, so we have to consider principal of argument will be equal to argument of z minus 2 pi. Do by yourself. Okay, this question I left for yourself. Here we have to stop our this lecture. Now next lecture we are going to discuss de Moivre's theorem. We have to prove, and we are going to do some numericals upon the de Moivre's theorem. By using de Moivre's theorem, we can find the roots of a complex number. How it will be, that we are going to discuss in our next class. Thank you so much for watching this video. Thank you.